My Surf Experience by Jose Melgar. What's currently the only technology that allows for non invasive live imaging of the body and the brain? Do you know what it is? Well, it's magnetic resonance imaging, better known as MRI. And magnetic resonance imaging has allowed scientists and physicians the ability to peer into the inner workings of the brain and the body. And very generally, that is what my research project focused on this summer. Before I get into my project, let me first introduce myself. My name is Jose Melgar. I was born and raised in Tampa, Florida, and I'm currently a student at the University of South Florida. I'm double majoring in physics and biomedical sciences, and if all goes as planned, I'll be graduating this December 2019. I'm the fourth of five boys, and when I earn my degree, I will be the first in my family to do so. So I'm very glad to have had this opportunity to participate in this program. Now let's quickly meet my professor and my mentor. This is Dr. Thomas Marisi. He's my professor, and this is Manish Amin. This is where I worked at for the summer, the McKnight Brain Institute. Now, before we get into my project, we have to go over a few of the basics of MRI. The most fundamental aspect has to do with spin. Here we have a hydrogen ion with its spin represented by an up arrow. Now, if we then apply an external magnetic field represented by the red dashed line with magnitude B, this causes the spins to tip over. The spins begin to precess around the main magnetic field and will eventually line themselves up with the main magnetic field. If we then apply a quick changing magnetic field in a perpendicular axis to the main field, then the spins will again tip over and precess until they line themselves up with the main field again. This is the property that magnetic resonance imaging exploits. Now, there are different ways to use these properties to collect information. The scheme that we use in our project is based on echoplanar imaging, or EPI. This GIF illustrates what is going on for a group of spins. We begin by tipping them over by 90 degrees. At that exact moment, they're still aligned, but then they will start to dissipate. If we flip them by 180 degrees, this will invert the spins, causing them to align up for a moment, and this echo is what we measure. Now let me quickly introduce you to the concept of K-space. The middle image here is the information that we collect. This is in K-space. If we perform a Fourier transform on this information, we can recover the actual image in regular space. The middle of K-space gives us the basic contrast of the image, and the outskirts of K-space gives us the detail. So we need to probe all of K-space to recover a decent image. The axis on the X here is essentially frequency, and the Y-axis is basically phase. Here's an example of how EPI goes through K-space. With EPI, we keep making the spins echo back and forth until we collect all of K-space that we need. So what we did in our project was collect data using gradients aimed in 60 different directions and with 9 different strengths. This scheme is represented as 9 spheres here, of different radiuses. We wanted to see if it is necessary to collect this whole data set, or if you could just collect a subset of it and still recover the same information. So we broke it up into these 2 subsets here. Now, after a bit of data processing to refine the original data, we can obtain a graph of the fractional anisotropy, which is shown here in this clip. This is a measure of whether water moves easier in one direction, all directions, or no directions. Most of the rest of our analysis is not as entertaining as this clip, but what we did was compare the principal eigenvectors between the same voxels, where a voxel is basically a 3D pixel. We compared the angles between the eigenvectors of the datasets. We performed spherical harmonic decomposition, and we compared the percent error between the datasets for different kinds of maps. This has been an extraordinary opportunity, and I will cherish the experiences that I've had here for life. I plan to apply to UF for a PhD in physics with a concentration in biophysics and use that degree to do research that would benefit humans everywhere. I would like to thank SURF for this opportunity, along with the university for funding it, and I would like to thank my professor and mentor for all of their guidance throughout this summer.